Oh, cool. Thank you.
I almost made you an admin because I just really do what you want. Just don't delete your stuff. I trust you.
Okay. It seems most of you got if and that stuff. Some of you are still having trouble with recursion, right? Do you guys have questions that you can articulate? Can you ask a question, or is just?
I found another way to make the program do what you want it to do, but as my classmate has told me, it's not what you want.
Well, actually, there is another thing which some of you are still having trouble with, and that is a lot more worrisome, which is this idea of returning versus printing and what do I do, right? This is going to be the most important thing. You need to be able to say, okay, right now I'm writing a function that does something, right? Who's going to call it? I don't give a hoot. My function needs to do the right thing, right? You need to be able to say, I'm an ant, I'm a horse, let me put my blinders and do this. I don't care who's going to call me, right? Like the string times, I think several people had trouble with. And they were printing, and they say it prints. It's like, well, you're supposed to return a value, not print it. Whether you print or not, in normal circumstances, printing would be sort of wrong because you're not supposed to. You're supposed to just compute a value, right? But definitely printing doesn't help, right? You still need to return the value. And the unit test would tell you that it's not working because they're not returning the right value. And I got some questions like, like usually my main things for this kind of assignment, right, which maybe tend to not be very useful. I just want you guys to exercise the functions, right? We are not yet to the point where when you are doing this in real life, you need to think about all those levels, right, and all those layers. But normally, still, right, you're doing one thing, that's what you're doing, and not the other stuff, right? So make sure that you can keep that in mind, and we'll try doing some things here. Now we are gonna pollute your brain with loops. Another way to get iteration, right? We have seen that we can get iteration through recursion, right? Another way is with an explicit loop. We say, go do this while this condition is still true. Does that make sense? And that will go over those statements over and over, checking the condition and verifying whether that's true or not. There are three loops that are more or less equivalent. The first one is a do-while loop. We we normally put braces, put whatever in there, and then while this condition is true. Normally, the stuff that goes inside the loop needs to change your condition, or needs to change the underlying variables for your condition, or you'll be doing that forever. And most of the time, you don't want to do it forever. You want to do it until something happens or while something is true or something like that, right? Maybe an example will confuse you even more. Read and sum. We are going to read integers until the user enters a 0 and calculate its sum. So we have int sum equals 0, and we're declaring another variable called input. We go inside the loop and we ask, we print, please enter a number. We read that number, and we add it to our sum. And we are going to keep doing this while that input is different than 0. what's going to happen when the user enters 0?
Going to terminate?
We do next int, right? We still add it. We are cheating. We can add it because it's still 0, right? So it's not a problem. And then it comes here, says, oh, that condition is not true anymore. Now I'm done. And it's going to return this one. Does this idea make sense? Some sense. Shall we go execute this thingy? Okay. We're pressing a scanner, right? Yes. Sorry? Thank you. Your programming is cool. One or 12. 0. It's always 12. Woohoo! Is this cool? Do you have a question? Ask, yes.
Oh, no. I was wondering where you put in the please enter a number. I was like, where did that come from? The top part.
Yeah, that's in this, right? Read and sum. Does that idea make sense? Now, a do-while loop always executes at least once. It should first ask questions later. Does that make sense? So I go do this thing once, and then I check the condition. We can also use a while loop. A while loop is ask first, two questions later. No. We write it. Oh, one thing about the do while loop, although many people don't ever use a do while loop, the semicolon at the end after the parenthesis is actually required. You need to write that semicolon at the end. The parentheses, just like with the if, are part of the syntax, but the semicolon is also part of the syntax. Because officially that whole thing is a statement-ish or something like that. We can write stuff like this, while condition, do whatever, right? We don't need the semicolon anymore. And it will check first and then execute depending on whether it needs or not. For example, we could calculate the power function by decrementing our exponent, kind of like factorial did it, right? With a while loop. We will start our accumulator, which I'm calling it tau. We start with 1. And while the exponent is greater than 0, we multiply our accumulator times the base, and we decrement the exponent. So what's going to happen? Imagine that we call power with base of 2 and exponent of 3. We're going to make power 1 is exponent greater than 0. Yes. Multiply. Base was 2, right? So now power is 2, and we decrement our exponent. Our exponent is now 2. We go back and check, is it greater than 0? Yes. So power is now 4, and exponent is now 1. Check again, is exponent greater than 0? Yes. Multiply again, power is 8, exponent is 0, and then go check again, is it greater than 0? No. Get out, return power. Does this make sense? Yes. We could also have another variable and count it up until we hit exponent, right? You will see with loops in particular, there is many, many, many ways to skin a cat. We will see that this is counting, so this really should be a for loop. A nicer example where a for loop wouldn't really go well is this. A function that checks whether a digit occurs within a number, and we are counting that 0, the number 0 doesn't have any digits. Just because if you go, right, zeros to the left don't count, because you could always write the number as 00001 if you wanted to. So those won't count. So we check, is the number 0, right? If it's not, so while it's not 0, we calculate the last digit, which is the number modulo 10. If it is the last digit, then we return true, right? If it's the digit that we're looking for, we return true. Otherwise, divide the number by 10. And go check again. Does this make sense? Some sense?
So are there advantages of using the while loop over recursion?
There are two things. In many cases, and we didn't really get deep into recursion accumulators, and the compiler may end up creating code that's more efficient. Most of the stuff that we use recursion for, we didn't really need recursion. There are some places where you really need it. But for the examples that we did, the compiler would probably generate code that's more efficient. But premature optimization is the root of all evil. Do you care whether the compiler generates code that's more efficient? Maybe, maybe not, right? Takes 1 millisecond instead of 2. Do I care? Probably not, right? Unless I'm executing that thing a million times a second, and then I do care, right? So it depends. Chances are that that's not the most important consideration. The other thing is which one is easier to understand. And that is kind of a matter of taste and style and team. I love recursion. I have no problem whatsoever with recursion. Many people, and that's, I tried to show you recursion first before loops, right? Many people, when they learn programming, they see loops first. They learn how to think with loops. Then when they see recursion, is covered at the last week of the semester, and so they find it hard, right? Because they have never seen it, and it's the last week of the semester, so you can cover it, and it's an advanced topic, and so many people never learn recursion. If you never learn recursion, then of course the while loop is a lot easier. If your team never learned recursion, right? Maybe you know recursion, but your team never did. You want to use while loops, right? Because they are going to be modifying your code. So it's that kind of that's kind of the main consideration, I would say. There are some things that look horrible if you don't know recursion, if you don't use recursion. They are completely equivalent. Maybe in 2 or 3 years, you take a theory of comp class and they show you that they are equivalent and how. But you can believe me, they are equivalent. You could do everything with recursion or everything with loops. But there are many things that are really, really hard to do one way or the other, usually. Like, especially they're trying to do recursion without, when the problem is recursive and you don't do it recursively, it's just horrible. But many times when you do loops, and the problem is one with loops, like you're trying to do matrix multiplication. I can do matrix multiplication with recursion, but why, right? I'd probably eat rice with a straw, but there is no particular reason to do that. So it depends on the problem, I think that's. But it also depends on who's going to be reading and who's going to be writing the code. Now, most of the time, our while loops end up with some initialization. This is actually not the most clear thing. We have our condition, and then we have something that modifies the loop variables, right? Like in this case, this. Why? Well, because if we don't change our loop variables, we end up in an infinite loop. A for loop lets me write this stuff in with a slightly different syntax that makes this pattern clearer. So we write we write our initialization, a semicolon, our condition, another semicolon, and our increment clause. So we could write power with a for loop like this. This is our initialization. We are creating a new variable, calling it I, and initializing to 0, while I is less than exponent, and we increment I. That's our increment. And inside the loop, we multiply times the base. What this does is it makes this pattern more clear. Does that make sense? We could write this with a while loop. Would be completely equivalent.
I guess the recursion would be the same as a while loop with if you're decrementing the variable, right?
You could do it incrementing.
Oh, okay.
As long as you pass the extra variable. Right? Like, okay, let's go play. Right? This, right? Let's do, how would we write this with a while loop? While, right, going like this, power, call it W2 to remind you of your taxes. We would move this outside, right? It's our initialization. Where does it go? Above, right? Somewhere before our for loop. This is, we're going to change it instead of for, we're going to write while. And then somewhere towards the end of our loop, we change our variable, right? This is exactly the same. In a way, that's what the compiler does. Does this idea make sense? They are completely equivalent. The compiler just does that transformation because the other syntax looks prettier, or arguably looks prettier. What do you do if you don't find the other syntax prettier? What happens if you prefer the while loop? What do you do? Use a while loop. Terribly, right? Whichever one you prefer. Does this idea make sense? In fact, shall we try them? So I'm gonna do to the third power. Oh, we don't have power. We have power 4 and power W2, right? And we probably need to make them private static or public static, right? They're not static, so we cannot call them from main. So we found a really hard way of writing 8 twice. Woohoo! Shows us that at least they produce the exact same result, right? Could we write this recursively while still having counting up, right, towards the exponent as opposed to counting down? We could, but it would require us probably you wouldn't call it I, but I could call it I, right? And then it would be as simple as if I is less than or equal to 0, return 1, otherwise base times power r base exponent, oops, I plus 1. If I greater than or equal exponent, right? Does this make sense? So when we call it, we'll need to pass it the initialization value, or we could write a wrapper function that just takes 2 parameters and calls this one with a 0 at the end. Does this idea make sense? Which one is easier to understand among these two?
So the top one looks kind of cleaner to me.
Well, look, right? Actually,
A little bit.
this one,
Okay, that one.
right? Why? Because, well, this is a for loop, right? I mean, the algorithm is almost, right?
There's less words.
The algorithm is a for loop, right? I mean, recursion is not hard. It's just, God, now what the heck is this? And I probably need to find a good name for it and that kind of stuff, right? I mean, it's not terribly hard. It's just not the greatest thing for this particular problem. But you can. In fact, there is a family of programming languages that don't have loops. They just do recursion. Scheme is actually a fairly nice language. Is used in several universities as the intro to programming, as the 1301 language, rather than Java or something like that. And it doesn't have loops. Just do recursion. That's it. It's one of those things. If you have a chance, make sure that you understand recursion. Make sure that you use it as much as you can. I have found it to be kind of one of those things that's a very good predictor for whether you're a good programmer or not. Not just whether you like it or not, you may not like it, but whether you understand it or not tends to be a fairly good predictor of programming ability. Maybe because it's taught at the end. But so we now can do all sorts of loops. Actually, this is complaining because I don't have some. Let's look at this other example. Whether a string contains a character, right? We are going to use a for loop, I equals 0, less than the length of the string, and that's s dot length, right? We're going to increment our variable. By the way, just like in math, for loops in particular, when the variable doesn't have a good name, we use I. Just like in summations, right, in calculus. Why? I have no clue, but we use I. And if we ever need more than one loop, what do we use?
J.
J. And after that?
K.
K. And then you stop, because if you're doing nested loops to 3 levels, you're probably not doing the right thing. Unless you're doing matrix multiplication, then you need a nested loop. But normally, that's not the right thing. Does this idea make sense? So in this case, this is I. Now we can ask, is the character at the position I, right, to be the character that I'm looking for? If it is, then I'm done. I know that the character is in there. If I end up getting out of the loop and I never found the character, what does that tell me? The character was never there, and so I should return false. Does this idea make sense?
Are these examples going to be on?
They are already.
Okay. Oh, okay.
They are in loop samples.
You have to go to his gets, or yeah, his get thing.
I will
yeah,
put them on the
not
notes.
detail
I'll-
yet.
Yeah,
I
I'll
think
link them
you'll
from
think
there. Actually, yeah. Yeah, I'll make sure to link them. But actually, can we get a volunteer? And we nominate a volunteer. Come write something. It's a lot more fun when you guys are writing code. No,
I'm not confident yet.
that's okay. Come in and you'll become confident.
All right. You have to help me though.
That's the point. This is pair programming or tent programming, whatever. What do you call a group of 7 people?
Quartet?
Septet or something like that. Okay. Let's write a function that counts the number of A's in a string. Does that make sense?
Counts the number of A's?
Yeah.
Okay.
Number of times the letter A appears in a string, right? So it's going to be public, static, because we write that.
Yeah.
What do we return? Int, right? That's a good name for it.
Counts 8 or counts A?
Count A's, or how about number of A's? I tend to do it like that. And
Yeah. A's. Number of A.
either one,
Is that-
whichever. Yeah, that's more grammatical, right? Exactly. And then what's our input? String. What kind of input are we getting? String. A string, right?
Okay.
So, what do you want to call it?
A?
If A is
Or
a
would that be
name,
too confusing?
That would probably confuse us, right? So A would be a terrible name, probably. Stealth is an okay name. How would we call it S? I think
S,
call all my
okay.
strings S. Why? Because I'm lazy and I like typing less.
That works.
Although you're, so, yeah, and open braces. So,
Okay, sweet.
okay. What kind of stuff do we need? We need some sort of counter, right? Int count equals 0. That sounds good to me.
In count?
Int,
Oh, int. Okay.
yes,
Wait, is this a function name or
it's a variable name. We're gonna
variable
create a
name?
variable.
Okay.
Type int, we're gonna call it count, because she suggested it.
And that was 0.
How do we start? When we
Oh, yeah.
start, how many A's have we seen?
We haven't seen any yet.
Cool. Now we're gonna do a for loop to iterate over this string, right? For and I equals 0, semicolon.
Oh, okay.
I less than what?
That's why equals 0.
Less than or equal to 0? But what do we do? When do we stop? If we're doing characters in a string, right? We look at the first one, the second, when do we end? When we reach the length of the string, right? So I less than
Okay,
as
we're
the
gonna go
length.
less than. Okay.
No. I equals 0. That's the first
Okay,
thing.
cool. We're
Then
keeping
don't
that.
close the parentheses. Don't close the parentheses. Semicolon. Space. I less than the other.
Oh, yeah. Sorry.
S dot length.
Length.
Yes. S dot.
Oh.
Like whose length? S.
I
S dot length. S dot length. Dot. Period.
Okay.
That thing is.
There we go. I don't know why it's doing that. It's lagging behind.
It is lagging horribly because it's a piece of
There we go.
hardware. Semicolon. No. Yeah. Good. Semicolon. And then what do we do to our I every step? We're going to count up or down. Up. We started at 0. We are going to end at the length, right? So we're going to count up. So plus I.
Okay.
You want it up in the.
You probably want it up on the same line.
up in
On
the
this-
same one as before loop.
Yes, because
Okay.
it's part of the for loop. Close, open braces, right?
Mm-hmm.
And we're good. So what do we do inside? How do we know? What do we need to be checking? So we have character number 2. What do we want to do with that?
Let's say,
If, okay, if s dot carat, right? Of I, what?
Equals?
Equals, yeah. Letter A. No, that would be the variable A.
Oh, yeah, the letter A. So,
Single quotes.
okay, yes.
That guy, yeah. So what happens? If it is the letter A, what do we need to do? Incremental counter, right? So count plus plus, or plus plus count. Doesn't matter whether we do count plus plus or plus plus count. Do semicolon and you're basically done. You're not quite done. What do we need to
More
do at the
done.
end?
Find a way to get out. You still have to.
Well, I always get out at the end of the function, right?
return count.
Yes, I need to return the count at the end. No, outside the loop. If I do it inside the loop, then I'm going to do it for the first character. Outside the loop, down.
Down. Okay. Turn counts.
Yep. Semicolon. And then Control Shift F or something. Control Shift F. No.
Oh, it's
sorry.
like we're
No.
finding something?
Close. Sorry, I'm
You're retesting it, right?
No, what I want to
Running it?
do is indent the right way. That return cannot be there.
Oh, okay.
It's horrible. Yeah. One
That's
more.
better.
Cool.
Sweet.
Does this make sense?
You're saying it does matter though, what side the incrementer.
Does it matter? Thank you. Does it matter?
Doesn't it? I think it does.
It's
I would say
like
it
matters,
does.
but if you ever are in a situation where it matters, you're doing it wrong. That thing has two effects. One is actually increments the count, right? Like plus plus count or count plus plus, increments the count. But as an expression, it evaluates to something. Does that make sense? If you do plus plus count, it evaluates to count plus one, to the original. Like if count is 3, plus plus count is going to yield 4, whereas count plus plus is going to yield 3. But still, count will be 4. Does that make sense? 99.9% of the time, it doesn't matter. But C++ programmers write plus plus. I write plus plus variable. It's slightly more efficient. Doesn't matter. Thank you.
You're welcome.
It matters with pointers though. Or something.
It matters with, actually it shouldn't matter. It shouldn't matter even with pointers. It only matters if you're doing stuff like,
Just trying to figure out a case when that would matter. 'Cause we're-
int a equals plus plus count. When you do this, right?
Oh, I see.
Then it matters because you are doing either one or the other.
Yeah.
Right? You're getting either 3 or 4, and so it could matter. Chances are that it's wrong. If you are relying on that obscure thing, you are doing it wrong. The compiler will understand you. Your teammates will not. And actually, your teammate may be you on a Friday afternoon. Does that make sense? Shall we try it? How about this? 1, 2, 3, 4, 5, right? Five, yay! Thanks. You see, you're good. You can do it.
It just takes me a long time.
Normal. Until you have done a million of them, and then these ones are easy, and the ones that you would be doing at the time take you a long time. It's normal.
I can imagine.
You'd be surprised at how low is the productivity of programmers. We are all doing this at our own level. That would be another good thing to do.
You said you work at Amazon, right? Through like a fabric company?
Sorta, kinda. Yes, I work at Fabric.com. On my resume, I put that it's an Amazon subsidiary because that's important. But
Could you find a reason why you would use that at maybe your job, for example?
stuff like this, right? In my job, and we'll get to see some of this stuff. We definitely use strings, of course. We use arrays often, which are kind of like strings, but of any other stuff rather than just characters. But most of the time you are talking about you are reading data from a database or writing to a database. But other than that, yes, we do this kind of stuff, like maybe not number phase, but what would be some string manipulation. And many times you also have already libraries that do stuff for you. But we have our backend is written in Java or Groovy or C#, depending. But and the front end may have a list of product IDs or something like that that we are doing stuff with. And it will be passed as a string to the other side, and the other side would have to go break it by spaces or something like that. That kind of string manipulation is fairly common. Or the other way around, I have it stored as a string somewhere as a configuration, and I'm going to convert it into an array for my JavaScript stuff. So I need to. String manipulation is fairly common. Maybe not counting the number of A's. Yeah. Some other cool examples of loops. What would be good? Let's try to convert this one into read an average. How about that? Except for one thing, but that's okay. We can talk about that stuff. I'm gonna do this. What do I need to do to my kind of read and sum to make it into a read and average? How do I calculate the average of a bunch of numbers?
Add them up and then divide by 2. Or no, divide by
number.
However many, right? So I need, besides the sum, I need a count, right? So here I'm adding to my sum, and then what do I do to my count? Yep. That's right-ish. Right? Of course, I shouldn't be doing this stuff. I should be doing what?
Why double?
Double is a floating point value. I shouldn't be using ints, right? Actually. Yep, just to have Java not complain because it's not double. So that allows me to do floating point arithmetic with decimals. Now I'm past 5th grade. Woohoo! It's actually not quite true. Floating points are weird, but for computers, because we want a finite amount of storage. So we store them closer to scientific notation. But for the most part, this would work. So we could do Oops. Sorry? Oh, oh, because I deleted in. Yeah, but it's running the old one. It's mine was 0.8, which is probably right. Passes the piano test. Could we write this with a while loop instead of a do while? Let me put it 2. Well, let me copy this one. Can we write this with a while instead of a do while? What would happen if we do this? Would this work, right? It will be obvious in a second, but yeah, that's important. Would this execute once or not? Would this execute the first time or not? The first time we enter the loop, what's the value of input? We don't know because we didn't set it here, right? And so this is actually complaining because we didn't set it. What can we do? That's the red is because we didn't set a value, and so the compiler is being nice and telling us. Actually, the IDE is telling us because the compiler would tell us. What should we set up input to? Anything other than 0 would work. 127. Sorry? Sorry? Would we add it? Is that what you're asking, or? No, we won't, because we would read first before we add, right?
Could you pass it through the while loop and set input not equal to 0?
The while loop doesn't take parameters, right? Actually, the only problem is this would actually, and actually this is wrong too. Oh no, this is right, but this is wrong, maybe. No, this is wrong. We are adding 1, right, to our count. So this should be count minus 1. We are counting 0 as a number. And it's the same thing here.
Is it the same? Because once you put in 0 for the while loop, won't it stop automatically and won't count?
No, it doesn't stop until it goes back, right? Here you put the 0, but it doesn't stop here. It still executes this. It still executes this. And then it goes check. Does that make sense?
I thought also when you get 0, it should stop.
No, it doesn't. There is no magic, right? The check is done at the beginning of the loop only. And that is important. Yes, there is no magic. The check happens only here. In the middle, it could be 0 or not, and that's okay. Does that idea make sense? Let me do something that may confuse you. Hopefully not. We'll read an average 2, right? Now I'm going to cheat. I'm going to use the debugger. Debug as, but do. I'm gonna set up a breakpoint here. And then rather than run, I'm gonna debug this thingy here. Debug.
You just hit F11 to debug.
Yeah. Tell it yes and see what happens. This messes up my screen, but it's okay. Don't overuse the debugger. It's useful to get you an idea of what is happening. It is bad if you use it instead of your brain. And so I tend to not show it at the very beginning because many people would use it instead of the brain. So we can actually put here things. If we do, God, I cannot see. I step over, and here it shows me my variables. So sum is 0, right? And if I can figure out what the heck is step over again, step over, and it doesn't tell me. Step into, step over, F6. Okay. Let me move this so I can see all of my variables. I have count and I have input, right? So it checks here. Prints that thing. What's it going? I don't see it go. Run. Oh, did it die? What happened? This is terrible on this screen. Sorry. I think this is where it's executing. Oh, so we have something. Cool. Wasn't reading until I had the enter, maybe. So now it's going to increment count. But this is horrible because we have too many things. If you had a bigger screen, it would actually make sense. Let me just finish the whole thing. 7, let's do -7. Let's do 1, and then 0, and it should get 1/3, right? Enter 7, -7, and 1. So life is good now. Now go back to the Java thing, which has less things on my screen. Any other things we can do with for loops?
Is there a way, if you, say you had a function that was looking for a certain type of number, like 1 through 5, is there a way to say something like invalid input if they put something that's not 1 through 5, and then ask for the same variable again without recursion?
You could actually, there is a way, and you'll have to find it. I tend to recycle assignments, both because now you understand them and so that's why I'm not doing it as an example. One of your assignments for assignment 4 is read within range.
Yeah.
With a loop.
Okay. I had to do that at work, and everyone was like, "Oh yeah, it should be just easy, and so I ended up using recursion after we learned recursion. It was super easy, but I was trying for the longest time to try to figure out how to do it with a while loop.
Yes, it's basically as long as you write a function, right? If you try to do it within something, it's gonna confuse you. But if you write it's a function, right? It's just ask. If it's right, then I return it. If not, then I keep asking. If you try to write a loop that inside has another loop or something like that, you're going to confuse yourself. But if you write functions, then now my main loop just calls read within range over and over, and life is good.
Okay. So one function will get the number you're looking for, and then the other function will actually process it.
Yes. And that way, you should try to make things as simple as possible. Let me mention one more thing about loops. We probably won't use them too much, but there are two other things that you can do with loops. One of them is break, and the other one is continue. A break gets you out of the loop immediately. Does that make sense? Of course, you normally don't want to just put a break because that would be as closing the brace, but you can put an if statement, and if something happens, then break. And that's slightly weird, but not too weird. There's another one which is called continue, which actually doesn't get you out of the loop, gets you back to where you checked the question. I don't think I've ever used a continue in a real life situation. But you should know that it exists. However, a break is sometimes useful. And so I could write things like this. Let me do this. So I could write while true, print it, read it, if does this make sense? If the input is 0, just break, and then the rest doesn't even happen.
Does the location of the break in the if input equals 0 break, does the location of that make any difference? Like, what if we put that
In the same line or something like that? No, it doesn't
if
matter.
we just put it higher in the line?
What
Say
do
we
you
put if input equals 0 break underneath the sum plus equals input?
this?
If we put those two lines, the if and break underneath the sum plus.
Oh, yes, that would matter. Well, maybe. If we do this, then it matters, right? Because we'll be breaking after this, right? It would somewhat matter. What would happen? we would add that 0 into our sum. Does it matter? No, because I can add 0 and it doesn't matter, right? So it's
better to just type the code as you're kind of going through the process.
in this particular case, the end result would be the same, right? So in that sense, it doesn't matter, but you end up doing one more operation. So yes, it is very important which way you put it. Both of them would be correct in this case, right? Some people like to write things like this. Many times it is more confusing because now you don't know where the heck you're going to end your loop. But sometimes it makes your life easier. And actually, sometimes people write this. Instead of while true, they write forever. No initialization, no conditions, no increment. By the way, it is weird. I never do it, or I normally don't do it, but you don't need the 3 pieces of the for loop. You can leave them blank or leave some of them blank. So this would be exactly the same as a while loop. A for with just the condition. And it's syntactically correct. It is dumb. You should use a while loop. But it is syntactically correct. Does that idea make sense? Let me write it back as while true. Cool. You have fun little assignment for due a weekish from today. Sunday midnight instead of Monday 7. So it's
Instead of Monday, what?
Monday 7. What time is it?
Oh, okay.
It's not quite a week from today.
Yeah.
Right? And I'm returning 2 minutes of your life. I usually take up too many minutes of your life. So this time we are ending 2 minutes early. If I can find how to stop this thing.
Alt F4.
This guy.